we think of love as our own, a modern thing, something for poets and songwriters. We swipe on apps, we go on dates, we talk about chemistry and compatibility. It feels so complex, so tied to our big brains and our complicated lives. But is it? Or is that feeling in your chest, that pull toward another person, something much, much older? Is it an echo from a time of stone tools and open savannas? Did early humans fall in love? The short answer is yes. Almost certainly. The love they felt might not look exactly like ours. They weren't writing sonnets or planning weekend getaways, but the fundamental machinery, the biological and emotional engine of love, was likely running strong in our ancestors hundreds of thousands, if not millions, of years ago. To understand why, we have to stop thinking of love as just a feeling. We have to start thinking of it as a survival strategy. It's not just a nice extra. For early humans, it was a matter of life and death. First, we need to break down what we mean by love. It's not one single thing. Scientists who study this, like anthropologist Helen Fisher, see it as three distinct but connected brain systems. Each one evolved for a different purpose. The first is lust, the sex drive. This is the most basic part. It's that craving for sexual gratification. It's not focused on any one person. It's just a powerful ancient urge to reproduce. It's driven by hormones like testosterone and estrogen. You can thank the system for the continuation of pretty much every species on the planet. It's blunt, it's simple, and it works. Early humans definitely had this. Every living thing that reproduces sexually has some version of it. The second system is romantic attraction. This is the part we often call falling in love. It's that obsessive, focused, exhilarating feeling. You can't eat, you can't sleep, you can't stop thinking about one particular person. They are special, they are unique. The world seems to revolve around them. This isn't just about sex, it's about winning a specific partner. This system is fueled by a different cocktail of brain chemicals, primarily dopamine. Dopamine is part of the brain's reward system. It's the same chemical that gets you hooked on gambling or chocolate. It creates motivation, craving, and focus. When you're falling for someone, your brain is flooded with it. It makes you energetic, optimistic, and willing to take huge risks to win that person's affection. It's a powerful engine designed to narrow your focus from everyone to someone. The third system is attachment. This is the calm, comfortable feeling of deep connection you have with a long-term partner. The excitement and obsession of romantic attraction eventually fade. They have to. No one could survive that level of intensity forever. Attachment takes its place. It's a feeling of security, of peace, of union with another person. This is the bond that keeps a couple together long enough to raise children. This system runs on different chemicals, mainly oxytocin and vasopressin. Oxytocin is sometimes called the cuddle hormone. It's released during sex, childbirth, and breastfeeding. It promotes feelings of trust, bonding, and calm. Vasopressin also plays a key role in long-term pair bonding. Together, these chemicals create a deep sense of connection that can last a lifetime. So we have lust, attraction, and attachment, three brain systems. Did early humans have them? We can't put a fossil in an MRI machine, but we can look at the evolutionary problems our ancestors faced. And when you do, you see that these three systems weren't just luxuries, they were essential tools for survival. The biggest problem our ancestors faced was their babies. A human baby is uniquely, profoundly helpless. A newborn foal can stand and walk within an hour. A baby chimp can cling to its mother's fur. A human infant can't do anything. It can't hold up its own head. It can't find food. It can't run from a predator. It is a tiny, fragile, demanding creature that needs constant, intensive care for years. And it's not just for a few months. Human childhood is incredibly long. This is the price we pay for our amazing brains. Our brains are huge. To get a baby with such a big head through a mother's birth canal, it has to be born prematurely, in an evolutionary sense. Its brain is still massively undeveloped. It takes years and years for a human child to grow its brain and learn all the complex skills needed to survive, how to find food, how to make tools, how to navigate a complex social world. Think about a mother, an early Homo erectus, let's say, 1,000,000 years ago on the African savanna. She has a toddler on her hip and a new baby in her arms. She needs to gather roots, berries, and maybe scavenge some meat. She needs to watch out for lions and hyenas. She needs to carry her children, feed them, and protect them. Doing all of that alone is a monumental task. It's almost impossible. Her children's chances of survival are slim. Now, Imagine she has a partner, a male who is bonded to her. He doesn't just mate with her and leave. He sticks around, he protects her and the children. He helps find food, maybe hunting or scavenging, and bringing it back. He helps defend their small camp from predators. Suddenly, the children's chances of survival go way up. The mother has help. The children have two protectors and providers instead of one. This is the evolutionary purpose of love. Romantic attraction, that dopamine-fueled obsession, evolved to make two individuals focus on each other long enough to form a bond. And attachment, that oxytocin-fueled connection, evolved to make that bond last. It's the glue that holds the parents together long enough to see their incredibly needy, slow-growing children through the long, dangerous years of childhood. Love is nature's solution to the problem of the helpless human baby. This idea is called the pair bond hypothesis. It suggests that the nuclear family, or at least a stable parenting pair, is not a recent cultural invention. It's an ancient survival strategy with deep biological roots. The emotions we feel, the crazy high of new love, and the deep comfort of a long partnership are the mechanisms that make this strategy work. So, what's the evidence? We can't dig up feelings, but we can dig up clues in bones, tools, and the very shape of our bodies. Let's look at our primate relatives. Our closest cousins, chimpanzees and bonobos, have very different social structures. Chimps live in large, promiscuous groups with a clear male hierarchy. Males compete fiercely for access to females. There's not much in the way of paternal care. A male chimp doesn't really know which infants are his, and he doesn't stick with one female to help raise them. Bonobos are more peaceful and use sex for social bonding, but they also live in promiscuous groups without stable pair bonds. But other primates, like gibbons, do form long-term pair bonds. A male and female will stay together for years, defending a territory and raising their offspring together. This shows that the capacity for pair bonding exists within our primate family tree. It's a strategy that can evolve when the conditions are right. For early humans, the conditions were definitely right. The extreme helplessness of our infants created an intense pressure to evolve some form of stable pairing. We can also see hints of this shift in the fossil record. In species where males fight each other for access to females, like gorillas, the males are much, much larger than the females. A big male gorilla has a harem of females. He has to be huge and powerful to fight off other males who want to take over. This difference in size between males and females is called sexual dimorphism. In modern humans, males are, on average, a bit larger than females, but not dramatically so. The difference is much smaller than in gorillas or orangutans. When we look back at the fossil record of our ancestors, we see a trend. Earlier hominins, like the Australopithecines lucy species, had a more pronounced size difference between males and females. This suggests their social structure might have been more like a gorilla's, with males competing for multiple females. But as we move forward in time toward Homo erectus and then to Neanderthals and our own species, Homo sapiens, that size difference shrinks. Males and females become more similar in size. This shrinking sexual dimorphism is a powerful clue. It suggests that direct, violent male-on-male competition was becoming less important. Instead of fighting each other for mates, males might have been starting to compete in other ways, perhaps by being better providers or more reliable partners. The evolution of our bodies hints at a shift in our social behavior, away from a system of pure male competition and toward a system of cooperation and pair bonding. A male didn't need to be a giant brute to succeed. He needed to be a good partner. Then there's the evidence of care. The fossil record is full of skeletons of individuals who survived for years with debilitating injuries or diseases. There's the famous Old Man of La Chapelle, a Neanderthal who lived to an old age despite having crippling arthritis and having lost most of his teeth. He couldn't have hunted. He probably couldn't even chew his own food properly. For him to survive, someone must have been taking care of him. Someone was feeding him, protecting him, and keeping him warm. At another site, Shanidar Cave in Iraq, archaeologists found the remains of a Neanderthal who had a crushed eye socket that probably left him blind in one eye, a withered arm that was useless, and severe injuries to his leg and foot that would have made walking difficult and painful. Yet he lived for years after these injuries. He was part of a group, and that group took care of him. This isn't romantic love, it's compassion, it's empathy. But it shows that our ancient relatives had the capacity for deep, long-term social bonds. They were capable of investing in others, of caring for them even when they couldn't contribute much to the group's survival in a practical sense. This web of social care is the bedrock upon which attachment and love are built. If you can care for an injured elder, you can certainly form a deep supportive bond with a partner to raise a child. It shows that the emotional and cognitive hardware was there. The brain itself tells a story. The evolution of the human brain is a story of expansion. Our brains got bigger and bigger over time. A bigger brain requires more calories. It also requires a longer childhood to grow and learn. This creates a kind of feedback loop. To support a bigger brain, early humans needed a higher quality diet, which meant more meat and cooked foods. Getting that food required cooperation, better tools, and smarter strategies. This favored individuals who were more social and cooperative. And how do you ensure the survival of an offspring with a brain that takes 2 decades to fully mature? You need stable, long-term investment from more than just the mother. Pair bonding becomes almost a necessity. The very evolution of our intelligence is tied up with the evolution of our ability to form lasting, loving relationships. Our big brains demanded love, and love allowed our big brains to flourish. We can also look at the archaeological record. Early human sites often show evidence of a home base, a place where the group returned to sleep, share food, and care for children. The presence of hearths, or campfires, dating back hundreds of thousands of years, suggests a central point for social life. Around that fire, pairs could have reinforced their bonds. It's where food was shared, a fundamental act of provisioning and care. It's where children were kept safe. The entire structure of early human life seems built around small cooperative groups, and the most fundamental unit of that cooperation would have been the parenting pair. What about the feelings themselves? Could they really feel that obsessive, crazy in love feeling? All the evidence points to yes. The dopamine reward system that drives romantic attraction is an ancient part of the mammalian brain. It's not a recent human invention. It exists to motivate us to achieve goals, whether that goal is finding food, winning a fight, or securing a mate. There's no reason to think the system wasn't active in our ancestors. Imagine a young Homo erectus man. He sees a woman from a neighboring group. For some reason, she stands out. His brain's reward system kicks into high gear. A surge of dopamine makes him feel focused, energetic, and intensely motivated to be near her. He might bring her a special piece of fruit or a well-made stone tool. He might try to impress her with his hunting skills. He is, in a biological sense, love-struck. His brain is telling him that she is a valuable prize, and he should do whatever it takes to win her. And if he succeeds and they form a bond, another set of brain systems would take over. As they spend time together, share food, and perhaps have a child, their brains would release oxytocin and vasopressin, cementing their bond. The frantic energy of attraction would soften into the deep, comfortable feeling of attachment. They would become a team. This emotional journey is not a product of civilization. It's a product of biology, sculpted by the relentless pressures of evolution. His language must have played a part too. We don't know exactly when complex language evolved, but as it did, it would have added a whole new dimension to love. It allowed individuals to express their feelings, to make promises, to tell stories, to reassure a partner. It allowed for a more complex understanding of relationships. You could talk about the future. You could resolve conflicts with words instead of just actions. Language would have taken the raw biological urges of love and woven them into the fabric of culture. So when we ask if early humans fell in love, we're asking if they had the biological capacity for lust, attraction, and attachment. The answer seems to be a resounding yes. They face the exact evolutionary problem helpless babies that pair bonding is so perfectly designed to solve. Their bodies, their brains, and the archaeological clues they left behind all point to a species that was becoming increasingly social, cooperative, and dependent on long-term bonds. Of course, their love would have been different. Their lives were unimaginably hard. They faced constant threats from predators, starvation, and disease. Life was short and brutal. Their relationships would have been forged in this harsh reality. A partner wasn't just someone to share your feelings with, they were your key to survival. A good partner was strong, resourceful, and reliable. Love would have been intensely practical. And it's unlikely that every single person formed a neat, lifelong, monogamous pair bond. Human behavior is flexible. Just like today, there would have been variation. Some people might have had multiple partners, some bonds might have been broken. But the underlying tendency, the biological default, would have been toward forming a stable pair bond for at least long enough to get a child through the most vulnerable years of infancy. This strategy was just too successful to be ignored. Even our jealousy has ancient roots. If a male is investing all his resources, food, protection, timing, into a female and her offspring, he needs to be reasonably sure those offspring are his. This is the evolutionary root of male sexual jealousy. It's a mate guarding strategy. Similarly, a female investing her reproductive life in a partnership with one male needs him to stick around and continue providing resources. This is the evolutionary root of female emotional jealousy. She's not just worried about him having sex, she's worried about him forming a bond with another female and diverting his resources and protection away from her and her children. These powerful, often destructive, emotions are the dark side of love. They are the security system designed to protect the most important investment an early human could make. When you look at modern hunter-gatherer societies, which live in ways that are, in some respects, similar to how our ancestors lived, you see pair bonding as a common pattern. People fall in love, they form partnerships. These partnerships are often crucial for raising children successfully. While their cultural expressions of love are diverse, the underlying theme of a special, bonded relationship between two people is a human universal. So, the next time you feel that spark for someone, that irrational, obsessive focus, remember that you are tapping into something ancient. That feeling is a ghost from the Pleistocene. It's a finely tuned piece of evolutionary machinery that was designed to solve the single biggest problem our ancestors ever faced: how to keep their big-brained, helpless children alive. And when you feel that deep, quiet comfort with a long-term partner, that feeling of home, you are experiencing the powerful chemical bond that held families together against the harshness of a prehistoric world. It's the glue that allowed our species to not just survive, but to thrive, to cooperate, and to eventually build the complex world we live in today. Love is not a modern luxury. It is our oldest survival tool. It's written in our DNA, wired into our brains, and it connects us to the very first humans who looked at each other and felt something more than just an urgy connection. Connection, a focus, a need to be together. They didn't have the words for it. They couldn't write poems about it, but they felt it. They lived it. And because they did, we are here.